Hello. So my session, a little bit left field, I think is a fair thing to say, but I'm going to talk about Terraform, which I'll address the why someone come to an EUC event to talk about Terraform in a second. But just a hello from myself. My name's Joe Walsh. I'm currently a senior solution architect working for CDW UK. I tweet, or I X, and I occasionally blog and put ramblings on my website. Just the usual disclaimer, views, opinions, my own. Please check documentation because I might be talking nonsense. So hopefully not, but we'll see. So session goals today. I'm going to talk about what actually infrastructure as code is and why we would use it. We'll talk about what Terraform is as well. We'll talk about how it works and also the sort of the elephant in the room bit, why it's relevant for EUC environments. You know, why have I come here today? Was I drinking beer on the train down or something like that? And you know, what's gone wrong? But I just want to relate to why I think it's relevant for EUC environments. We'll talk about getting started and kind of the installation and code samples and demo could be kind of, you could spend a day, you could spend a week, you could spend a whole year, you could spend several years, which is kind of what I've been doing, getting comfortable with Terraform. So it is a little bit whistle stop, but I'll provide some resources as well just to help develop and sort of carry on using it. So appreciate there's lots of different infrastructure as code tool sets out there. You know, you might have used Bicep, you might have used Ansible, you might have used Puppet or something similar, but infrastructure as code is essentially a method of managing and provisioning infrastructure via code. Fairly self-explanatory. Typically falls into two different types, so imperative or declarative. I'll come on to that in a second, but imperative is typically do this, so you know, go and build me a virtual machine. Declarative is more a build me a virtual machine. You describe the infrastructure that you want to be built. It's often integrated into version control systems, so something like GitHub or Git, and it's often...
Do you mind putting this on? You can probably find that's a bit louder.
Yeah, no worries. Sorry, I'm like a orthodox mumbler.
Is that better? Can everybody hear me?
Is that better now?
Yeah, that's better.
Yes, cool. Sorry, I do mumble, I apologise. And often infrastructure as code can be edited and managed in most sort of common tools and platforms. So, you know, lots of people in here probably use GitHub, you probably used VS Code, you probably used Azure DevOps and that sort of stuff. Usually it's adopted as part of a wider DevOps strategy, but not always. Kind of my use of Terraform literally started because I only used to get 120 quid a month in Azure credit. And it was a bit of like a sort of penny drop moment. I didn't need to sort of leave things running. I could build it as and when I needed and then destroy it when I'm finished. And that's kind of snowballed. So one of the things I have to do in my job now is demo environments to customers a lot. And I have a Terraform cloud environment that I literally deploy. I can be really lazy, get my phone out, trigger it on the train whilst I'm trying to wake up with a coffee. It sits there, builds me an environment. If I left that environment running, it would cost sort of $3,000 a month. But running it for an hour or two, it's like 3 or 4 quid, so far more efficient. It also allows a move away from ClickOps. You know, we're all human beings. If we all try and do the same task 100 times, you know, you might, on a good day, get it right 99% of the time, but actually taking some of that uncertainty out is really useful. And it provides us with options to actually version control infrastructure. So somebody can write code, they can commit it to a repo, they can deploy it in a pipeline, somebody else can come along, make a change to that, that can be reviewed, denied, approved, whatever it may be, but there's an audit trail there, there's history to it as well. So I talked just a second ago about imperative or declarative code. Just a couple of examples to kind of set the scene on that. So imperative would define a task to be carried out. You know, this is a very, very simple Azure CLI command basically saying, please go and create me a VM. If you ran that more than once, it would fail because the VM already exists. In terms of declarative, so here's an example from some Terraform I've written. Hopefully that's readable okay on there. It actually defines what we would like to be created. So if we ran this multiple times, we would just get a message saying, I've already built this. It's already done. There's no change to carry out. So it's kind of, in one regard, in imperative, you are asking for a task to be done. With declarative, you're asking for something to be built. So that's just a subtle difference between the two. So why use infrastructure as code? Now this is probably the most lacking in content slide known to man, because you could probably list 100 plus things on this slide. But for me, it kind of boils down to these three. Appreciate that's perhaps different for other people, different for other organizations, so on and so forth. But cost is a huge factor. You can be more rapid, you can make changes, you can test those changes, you can spin up test environments. This kind of comes back to my comment about, clicking through a portal. We're all human beings. Do the same thing 100 times, chances are it will go wrong. So when you have that repeatability, cost is a factor there. Speed as well, faster deployment due to less manual intervention. So, you're not clicking around, your testing becomes easier, less prone to human error. We're all, as I said, all human beings. And it kind of enables those DevOps methods and practices. So, it might start with, hey, look, we spin up our test environment in Terraform, and then that might snowball. Oh, actually, we're going to build this new prod application using it, and we're going to put the code in a Git repo, and we're going to have version control, we're going to have approvals, and that sort of thing. Risk is also reduced, reduced through the fact we can test, reduced through increased consistency, reduced through version control, being able to see what other people have done, approve before it happens. Again, it sounds like I'm bashing the human being a little bit when I say that, but I think it's important. It just, it sort of enables the reduction of risk. I've used this slide about 1 million times, so apologies if anyone's seen it before, but I think when you talk about infrastructure as code, the benefits are cyclical in nature, so it starts to snowball. By using infrastructure as code, things become more repeatable. Because things are repeatable, our speed of deployment increases. Because of that, we minimize risk, we become more consistent, we become more reliable than clicking through a portal or building something manually. It gives us then the ability, considering all of these things, to write once, deploy many times. Maybe you're an MSP, maybe you have 10 versions of one application. Well, great, one set of code can be used multiple times. Again, the duplication, that factor, let's say you sell an application to your customers or you build out hosting environments, the ability to write the code once and deploy multiple times, again, just adds to the benefits. And it all snowballs. And this is just a small subset. Again, there could be 1 million things on this slide, but I think these are probably the most important ones. I can use Wikipedia because it's not a university. So other platforms are available as well. I'm talking about Terraform because I like Terraform. I think it's really easy to read, and for me, that's been a big factor of perhaps why I've sort of gravitated towards it. But if you're getting into this sort of area, looking at infrastructure as code, have a look at other options. Play with other providers, other platforms, and just get a feel for how they work. Get an understanding of them. You may find that others are better suited to your particular use case. So we'll talk about what actually is Terraform. So Terraform itself is an infrastructure as code software tool. It can interact with a wide range of platforms and environments. Quite a common misconception, something I've encountered in my role, is people think it's cloud only. It's not. It can be used on premises as well. So it can be used in both cloud and on-premises environments. It can also be used to combine the two. So on-prem plus cloud, cloud plus cloud, whatever it may be, Terraform can do that for you. So typical example might be you may use Terraform in your on-premises estate and have DR in the cloud, where you could use the same Terraform files, the same deployment to control both of those. You could have cloud and cloud. You could do AWS on one side, Azure on the other. Lots of different options. Really important aspect with Terraform is the concept of a provider. So a provider actually allows Terraform to interact with a target API. So that might be a vCenter server, it might be AWS, it could be Azure. Lots of different providers are available, and I'll come on to that in a second. One of the huge benefits of those providers is that the Terraform aspect stays constant. So the functions that you might use in Terraform, the code you might write, the familiarity you will build, that stays the same. Just the method of actually interacting and creating resources changes slightly. So once you learn Terraform for Azure, for example, it's not a huge learning curve to learn AWS, just to give you a practical example on that. So the long and the short, providers add functionality or features to Terraform. Three main varieties. So Community Edition, that's what I'm using today. That's what I have on my laptop. That's what you'll see me sweating about in about 10 to 15 minutes' time. There is also Terraform Cloud, which is essentially a cloud-hosted version of Terraform. I'll come on to cloud in a bit more detail in a second. There's also an enterprise version, so self-managed for sort of larger custom deployments, perhaps more enterprise scenarios. Just something to note as well, Terraform Cloud is actually free for up to 500 resources a month. So I'm lucky enough to be in the HashiCorp Ambassadors program. I got given credit for Terraform Cloud, and despite my best efforts, I cannot incur any cost in it building my lab environment. I've tried, but I can't make it big enough. So if you'd like something where you can just build an environment in Terraform, point it at Azure, point it at AWS, have a look at Terraform Cloud because it's awesome, and it probably won't cost you anything. So just need to cover off authentication. Obviously, demo and lab environments probably going to authenticate at the CLI. Maybe use a service principal if it's something perhaps a bit more detailed, or you're deploying in a pipeline using Terraform Cloud, Azure DevOps, GitHub Actions, something like that. Today, I will just authenticate at the CLI, and I've already done that, so we're sort of ready to go. In production environments, chances are you're not going to use the CLI, but you'd be using a service principal or a managed service identity. I'll switch in a second and just show that, but the guidance and the documentation from HashiCorp on how to authenticate to each cloud provider is really, really comprehensive. So don't spend any time sweating about that because it's all covered. So just an example here. So this is just a screenshot of the Azure RM provider page. Shows all the different methods for authentication. Each one of those has a workable example and takes you through the process. So again, it's all covered and made really, really easy and straightforward. So I talked a little bit about providers a moment ago, but before we can actually run Terraform, we need to add a provider because we need to give it the ability to communicate with our target API. So there's a huge list of providers, some maintained by HashiCorp, some by third parties. Pretty much everything you could want is available, give or take some perhaps more niche areas. But in simple terms, those providers enable communication with platforms or services outside of Terraform. So think VMware, AWS, Azure, Google Cloud, whatever it may be. My demo is going to be based on Azure, so I'll be using the Azure RM provider. Just in a second, I will switch to that. Okay, isn't it? Yeah, so this is just I've opened up a browser. This is the Azure RM provider. This is an official provider maintained by HashiCorp. Using the provider is very straightforward because they just give you a block of code to do it. So the documentation literally couldn't make it any easier. You copy that, you put it in a provider file, Terraform downloads it at the time of initializing. The other aspect I really like about Terraform, and it's not really anything to do with the tooling, it's all down to documentation, is how easy to use this reference library is. So let's say we want to go and build a Windows virtual machine. Well, I would go here and I would type Windows, if I could spell virtual. It's not looking good for the demo if I can't spell, is it? I would click on this and it would actually give me all the code I would need to go and deploy a Windows virtual machine in Azure. And it's not just a case of giving some code that's half finished or just gives you the one little bit you need and you've got to go and work out the rest. This block here I could literally copy and paste into a file and go and do a deployment. So it's a workable example. And I think that's, certainly for me, I don't come from a programming background, I come from an infrastructure background, so the learning curve was made significantly easier by the fact that this documentation is provided as well. Just to quickly show the other providers as well, I'll just come back here, so just to give you an idea. Yeah, so there's 36 maintained here, sort of official and partner ones, but you can see all of the stuff you could want, AWS, GCP, Azure. The random provider is really interesting as well. I'll come on to that in my demo a little bit later, but you can start to build in randomization and security. Options to work locally, there's time aspects, Azure AD, Terraform Cloud, there's pretty much an endless list of the typical aspects we could want to play with. I believe there's also a Citrix Cloud one now. I think that was announced within the last week or so. So yeah, we've covered off the provider, but loads of different providers available. Again, if you can't find something, chances are there's probably a community provider for it as well. So perhaps there's something that's maintained by somebody in the community, but for most of the use cases, there is an official provider for what you would require. Again, AWS provider, another example, exactly the same as the Azure provider. Here's the code you need to use the provider. Here's the documentation. It will take you through authentication, all of that sort of stuff. And also then you've got the reference library on the left that just gives you all of the examples you need to start building resources. So what's the process for running Terraform? So typically, Terraform files are stored in a folder or a repo, perhaps if it's a remote deployment, and normally referred to as TF files, amazingly, unsurprisingly, because they have the extension TF. Those files actually define the infrastructure and its configuration or any changes. So don't just think of that in the case of, for example, build me 3 VMs. It might also be a change. You might have built 3 and then changed the configuration to ask for 4 to be built, as an example. At the time of running Terraform, those files are then analyzed, turned into an execution plan, and then we can apply our changes. Just a note on those files as well. If you, for example, were looking at perhaps let's take a PowerShell script, just as an example, and it ran through building out resource groups, VMs, lots of different resources. That could be a very, very long, difficult file to read. Now, there are options to split that, obviously. With Terraform, you can actually split out those files. So you can have, for example, one for resource groups, one for networks, one for virtual machines. And actually, Terraform will look at those and build out a dependency plan and a map for you. So it will understand, okay, I need to build resource groups first, then I can come on to virtual networks, then I can come on to subnets. Because the subnet is made, I can now make the network card, and because the network card is made, I can now build the virtual machine. So that's actually built out for you in Terraform. So that's, again, another very powerful example of where it's sort of picking up some of these elements and kind of taking care of things we'd otherwise have to consider and think of. So a few stages. There are others, but these are kind of the ones you'll use when you're getting started and starting to learn Terraform. The initialize phase, so that actually initializes, again, unsurprisingly, Terraform. It downloads any providers we've defined. It initializes the binaries, and at that point, we're then ready to go. Plan is the next phase we'd want to run. So plan will actually examine our files. It will, check they're valid and that what we're asking it to do, it can do. And then it will actually give us an execution plan. It will tell us, this is what, based on your files, I'm going to do within whatever environment we've asked it to go and deploy against. So, for example, in my demo, you'll see it will say I'm going to build sort of 30+ resources in Azure. Then you'd actually get to apply. So all plan will do is tell you what it's going to do. It won't build anything at all. So you can run plan completely in the comfort and safety, knowing it's not going to touch your infrastructure. Again, pretty handy when you need to test something. Apply will actually rerun plan, but then it will ask you a question, and it will say, would you like this applying? Obviously, if you say no, it won't apply. If you say yes, it will. So that's the apply phase. The opposite of apply would be the destroy phase at the end. So yeah, pretty self-explanatory on that one. That will destroy any infrastructure that's been created by Terraform. So when you get started, these are the typical 4 commands that you'll be using and running, and I'll show you these in the demo as well. So I can't talk about Terraform without talking about the state file. So the state file is actually a store for Terraform, and it stores effectively a working knowledge of the infrastructure that Terraform's built for you. So if you ask Terraform to go off and make 3 resource groups, in the state file, if you have a look at it, you'll find details about 3 resource groups. The state file is used by Terraform to create those execution plans. So for example, if we do a deployment of 3 resource groups, 3 virtual machines, and we then ask for another resource group and another virtual machine to be created, the state file is what Terraform will use to work out that delta. And that's how its execution plan is created. Just a note on state, typically 2 different kind of operating methods. So local state, that's what I'm going to use today. Pretty much the default setup. That's for learning, testing, labs, development. Doesn't really lend itself to kind of more enterprise or multi-user deployment. Remote state is really when we're starting to use DevOps tooling, we're collaborating on code, that sort of stuff. That's really where that will come in. It's worth noting as well, if you use Terraform Cloud, it will manage the state for you. So you don't need to worry about a storage account or anything like that. Kind of one final point on the state, so treat it as sensitive. The state file will store information about your infrastructure. So for example, if you're perhaps generating passwords or storing, you've got some sort of service principal, or perhaps you've got an IP address for a device that you're terminating a VPN or something like that, those will be written to the state file, so it should be treated as sensitive and secured appropriately. So just talking about ways of working. So this is just a local example. Everything done on a single machine, and this is how, all being well, my demo will function today. So you'd have somebody working, creating code, modifying code on a single device, saving that into a local folder. Terraform would then run, it will compare that code to the state file, and then infrastructure will be created, updated, or destroyed. And that's pretty much the sort of the go-to, the starting point, how we'd all start on this kind of journey. And if you are looking to get started, this is exactly how I'd recommend you do it. Keep it all simple, one machine, don't complicate anything. Now, the problem is, that's all well and good, but if I'm doing a customer's deployment, I've created my code, everything's looking great, I'm about to hit that deployment button, the customer's like, yeah, can't wait to get it deployed, and then I win the Euro Millions, yeah, it could cause some problems because I'm probably on a desert island, not really that interested in what the customer's doing, so this is a more typical example. You know, we've got two people actually creating and modifying the code. We're then saving that in something like GitHub, Azure DevOps. Doesn't have a dependency on a local device. Doesn't, matter if one of our laptops gets stolen, lost, whatever it may be. Someone goes off sick, wins the lottery, whatever. All of our code is stored remotely. Terraform would then be run in a pipeline, so something like Azure DevOps, GitHub Actions, Terraform Cloud. The state file would be in Azure Storage, maybe an S3 bucket, whatever that may be. Somewhere secure, somewhere remote. Our infrastructure would then be created, updated, or destroyed, but without that dependency on a local device. So just coming back to this again, if someone loses their laptop or loses the state file, we have a problem. We don't in this scenario. It's also worth noting that those people don't need to be in the same room. So you might have people all around the world, working on different infrastructures, working on different parts of an infrastructure, different time zones, whatever it may be. But it certainly opens up options and just allows you to think a bit more out of the box in terms of actually managing that infrastructure. Excuse me. Okay, so why is Terraform useful in the EUC world? So I think this is probably a combination of fact and opinion, I think it's fair to say on this slide. So some of these probably we could argue are facts, some of them are probably my opinion, but interested to hear thoughts, certainly open to discussion. But for me, this is why I think it's useful in the EUC world. Creating infrastructure repeatably, in different locations, platforms, and regions. Again, prior to me moving into architecture, I worked as a consultant. Terraform there was kind of the bread and butter. Being able to go into a customer with a known piece of good code that's been deployed before, proven, it stood the test of time, means I can get going quickly, we can reduce perhaps the cost of the job. It really enables that sort of repeatability. Rapid deployment and testing. I have limited credit to use in, say, an MSDN subscription, and I want to quickly test a sort of sample deployment for a customer before I go and waltz onto site saying, hey, I'm ready to go, it's all amazing. Well, I can do that and test that, so it certainly enables that. Cost-effective test environments, I talked about my demo lab that I use, but it really does enable those to be very cost-effective, and it gets you to that kind of per-minute billing, the sort of utopia of a cloud environment, if you're sort of creating something and then destroying it once it's not required. Scaling, really important as well, so the ability to scale up, down, in or out as required. Perhaps we could start with a small environment, and then by changing a small variable, we can scale up to have perhaps DR in another region or something like that. Again, expansion's another key factor. So you might have perhaps one or two Azure regions, and should there be a problem, should you have, take on some contractors, or, we get a pandemic or something like that, the ability to expand, again, very, 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 very beneficial in that scenario. Working safely as well, and in a standardized way across distributed teams. So I would argue that applies to infrastructure as code in general, provided the right practices are put around it. So putting those in a repository, using version control, having the ability for somebody to check somebody else's work before it's actually deployed. That sort of standardized way of working in distributed teams is certainly very valuable, I think, in the EUC space. Kind of already covered this one, but write once and deploy many times. Being able to do that certainly saves time. Time is money, right? And last but by no means least, version control of infrastructure as well. So the ability to have a known configuration that defines infrastructure to be able to roll back, roll forward, whatever it may be, clone that, deploy it somewhere else, I think is pretty valuable. So installation, interestingly, the HashiCorp docs actually just give a chocolatey line. So if you are using chocolatey, you can just do a choco install Terraform. I would recommend that you do the Azure CLI and VS Code as well. obviously please don't edit it in Notepad because you may start to lose sanity. Take advantage of VS Code and the extensions available. You can also just download the binaries, and there's Homebrew for OS X, there's installation for Linux as well. So pretty much whatever you want. It's very, very easy to get started. It literally takes about 2 minutes to get everything installed. So. The VS Code as well, so there's a really good plugin that's maintained by HashiCorp. Things like IntelliSense, you get that syntax validation and highlighting, code navigation, code formatting, snippets, and integration to Terraform Cloud. So again, just install that plugin, it will make life very easy, very straightforward. Excuse me. Also, again, this probably could be the subject of another session in itself, so there's just going to be that slide on this, but if you need a helping hand, then GitHub Copilot is really good, as is ChatGPT or Bing Chat. You know, here's an example. So I asked Copilot to write the Terraform to create 2 public IPs in the UK South region, and I added a curveball. I asked it to do it using the count function. I don't want duplicated code because I'm lazy and I only want to read a really small block. So that's what it spat out, which is perfectly valid code. It's actually given me the provider, the block at the top. So it said I need the Azure RM provider to do that. It's given me an Azure RM public IP, which is the type of resource we need. It's added the count function and said, you've asked for 2. Well, I'll give you 2. And if you look as well, the naming, it says count index. So it's actually going to append example, and then it'll be example-0 and example-1. So it's actually building that out. There's no sort of, we're not going to get an issue where it tries to name 2 resources the same. Interestingly, it's added a dev tag. I'm not sure where that's come from, but it's managed the rest. But it's also worked out that in order to create the 2 public IPs, that I do need a resource group. And it's defined that resource group for me as well. And you can see on line 10, that resource group is actually referenced by those public IPs. So pretty handy, pretty useful. If you are getting started, it's definitely something I would recommend checking out. Right, now the time where you'll really start to see me sweat. But I'm just going to do a demonstration deployment now, just to show you what the code looks like, give you an overview of how you would actually go about doing that. All you need, if you want to have a go at this demo at any point, is Terraform, VS Code, the Azure CLI, and in this case, you will need an Azure subscription to deploy into. Everything I'm using to demo is available in this GitHub repo as well. If you just go to github.com/jakewalsh90 and look for Terraform, you'll find it there. But it's all available. You don't actually need to write any code. You can just have a go at the deployment yourself. Just bear with me a second. Okay, is that showing up okay and readable? Yeah. Cool. Right, we're logged in. So what I've got here is just a what I call a single region Azure Base Lab. And it's a very small Terraform environment that I wrote basically because every so often I get asked, can you test functionality X or demo Y? And I need just a quick environment I can blast down, takes under 10 minutes to deploy, and it just gives me a very basic Azure environment, some resource groups, some VNets, a machine I can promote to a domain controller if I need, as an example. And it's kind of designed just as a, when you get those ad hoc requests like I do in my role for demos, for quick testing, that sort of stuff. So it's also a really good place to start if you just want to try out a deployment. So I'm just going to go through the files, and then we'll trigger the deployment. Hopefully it'll finish in the time, but if not, I might just have to show you some of the bits and bobs and what it deploys. But as I say, it's just to give you an overview. So a number of files here on the left. The first is the provider. So you'll notice I'm actually using 2 providers in this. The first is the Azure RM provider, and that's this block here. That's because I'm creating resources. I'm going to be doing a deployment to Azure. The second is the random provider. Now, the random provider I'm actually using because through this environment, I want to randomly generate some strings. I'm actually using those randomly generated strings as passwords for the VM. So if I handed a copy of this to 10 people in the room and asked each one of them to go off and deploy, every single one of those passwords would be different. And if you deploy this 10 different times, you will get 10 different passwords. So this is another really good example of how you can build in that security from the outset. So just before we get into the code, I'm just going to show variables.tf. So variables actually lists out, quite literally, that's all it is. It lists out the variables that we must give as a minimum for this deployment to work. So I've got some environment tags, I've got a region, I've got a naming code for that region, I've got a CIDR range for that region, I've got a count for the number of VMs, I've got a VM size, so the SKU of the virtual machine I want to be created, and I've got a username to use for admin. No variable for password in there at all. You know, that's all generated using that randomization that I talked about. There are some optional features in this environment. So Azure Bastion, some baseline resources for AVD, a virtual network gateway, and Azure Firewall. So for this demo, I'm keeping those off. Obviously, it would take a little bit longer to get those deployed. So that's our variables. Then we have the terraform.tf vars file. Essentially, this answers that variables.tf. So if we deployed this environment without that tf vars file, we'd be prompted to enter a value for all of those items in that variables file. So this is just answering the questions, really. You'll see all of the optional features are all set to false. So before we get onto the code, I'm just going to trigger the deployment because it takes about 10 minutes, and we'll obviously have a look at the code whilst that's deploying. So in order to start that process, we'll do Terraform init. And what you'll see is it just going off and grabbing the versions I've requested and installing those for me. Cool. So Terraform is now initialized, and we can start working with Terraform. We can start planning our deployment and getting ready to do so. So the first thing we're going to run is Terraform plan. So actually, interestingly, in this lab, you'll notice I'm using one of those IP checker websites, and I've committed a little bit of no-no in this lab environment in that the VM actually has OpenRDP. Now, obviously, you wouldn't do that in production, but for a lab environment, you know, keep it simple, just OpenRDP. I'm actually setting an NSG on that public IP on that virtual machine's network card that actually goes off and gets the client IP and sets that with a rule so only I can get to it. So small bit of security just in there sort of from the outset. So here we have 36 resources to add, which is good. It's also saying that there's none to change and none to destroy, which is really good as well, because if there was stuff to destroy, it probably says I'm in the wrong tenant and the customer is about to phone me up and tell me bad things have happened. So you'll just see here, you know, for example, let me scroll up to the top, show you a few of these resources.
In this example, you are already authenticated against Azure CLI, right?
I am, yeah. So I've basically done an AZ login, and then I've done an AZ account set and defined the subscription. Yeah. So that's the only two things that have been done. Yeah. So you can see here just a few of the items it's going to do. Let me just pull the terminal up a little bit. So we've got, it's going to go off and build the availability set. It's going to go off and create a key vault. It's going to go off and it's putting some access permissions into that key vault. There's a password being created. There's a disk being created there. Got a network interface being created. And you can, if you want to, I won't go through it all because we'll be here all afternoon, but you can go through this line by line if you do need to check that deployment. I'm just conscious of time, so I'm just going to run the apply now. So the last thing we would need to do is just run Terraform apply. Now, you'll notice this is going to rerun plan. So whenever you run apply, it will also run a plan phase because you might have run plan, made a small change, and then you need to rerun apply. So it's just important that's rerun again.
Okay. So I love automation. I love the DevOps mindset. I think you're entirely correct about the advantages of this kind of architecture.
It's a book's coming, though, isn't it?
There is yeah.
Sensitive more for you.
But I do find that there is reluctance within organizations to adopt these kind of tooling, to adopt this kind of DevOps mindset. So I was who here in the audience uses DevOps tooling in their environment? So there's still a lot of people who don't use this kind of tooling.
It is a learning curve, and that's, you know, I won't sugarcoat it. It takes time. It takes change, not just technical change, but also kind of, I hate the phrase, but hearts and minds. You know, people have to want to do it, and I think, you know, in some regards, that probably is just as challenging as learning the the actual technical side of things, definitely. I'll just trigger this apply so we can see this running. I'm just conscious of time. We'll let this run for a few seconds, then I'll just demo some of the resources it's created. So just a note for anyone creating anything. Whilst you're actually building stuff, you may actually see Terraform telling you that things have been created, but you won't see that in the portal. So just something to bear in mind. The portal is often a few seconds behind what your code says. So it's not that here we go. Not that I'm sort of trying to put you off or anything like that, but you'll see here, for example, we've started to get resources. So let me just put a filter in here. So let's just put resource group. We'll get some resource groups. I'm just going to filter it to the base lab one so you can start to see what's been built there. But you'll see here, so these are resources that Terraform's actually been creating. So we've got a virtual network, we've got a public IP, we've got NSGs, we've got network interfaces, a key vault, some disks. Conscious of time, so I won't sit there and let it run through all of that because we'll be here for longer than I've got. But just a final few bits and bobs. I'll flash that one back up on the screen. If you do want any of that code, it's all in that GitHub repo, so that's really the only URL you will need. That also has a full guide, so everything I've gone through today is explained A to Z in that repo as well, so please use that. If you get issues, reach out as well. Interested to hear feedback. And just let me know how you got on. And that's basically everything. So yeah, happy to, if there's time, take any questions, but thank you.